Very good morning to all. My name is Manoj Kumar, Assistant Professor, Department of Computer Science and Engineering, Ajay Kumar Garg, Engineering College, Ghaziabad. Today in this video lecture, we will learn about the virtual memory and page replacement algorithm in operating system. So, this is the table of content that I will cover in this lecture. First, we will discuss about the virtual memory. After that, we will see demand paging, and then we will learn about different page replacement algorithm like first in, first out page replacement, optimal page replacement, and LRU page replacement algorithm. After that, we will see some problems on the basis of these page replacement algorithm. So, first is the virtual memory. What is virtual memory actually? So, whenever a process executed by the system, then it is necessary that that process must be available in main memory. First, operating system load a process into main memory, and once the process is available in main memory, then CPU fetch it from the memory and start to execute that particular process. But what is happening nowadays, the process size is larger than the available main memory. So, if the process size is larger than available main memory, then in that case, how we will execute that particular process or how we will execute that particular program. So, for that scenario, the concept of virtual memory exists. Okay. So, if our program size is larger than the total available main memory in the system, then how we can load that particular program in the main memory, or what is the way to execute that particular process from the system. So, for that particular purpose, we will use the virtual memory. So, virtual memory, it is a section of hard disk that set up to emulate the computer's RAM. It means it acts as a RAM, and to achieve the virtual memory, to implement the virtual memory, we use the concept of the paging. We will see later. So, what is demand paging? So, before understanding the demand paging, at first we should know about the paging. What is paging? So, actually what happen in case of paging, suppose this is my particular program. This program is divided into equal or fixed size of partition. Suppose this is partition 1, this is partition 2, this is partition 3. This is my program. Okay. Now, this particular section is known as page. So, in case of paging technique, logical memory is divided, or our program is divided into equal size of partition. In the same way, the physical memory or RAM is also divided into equal size of section, and the section of our program or logical memory is known as page, and the section of main memory or primary memory is known as the frame. Now, we have to and this division is carried out in such a way that the size of a particular section or size of a particular page must be equal to the frame size. It means page size should be equal to frame size. Now, we will put these pages into memory. So, in case of paging technique, we simply divide the logical memory into equal size of partition, and a particular section is known as partition is known as the page, and we also divide the main memory into equal size of partition, and the partition of main memory is known as the frame. Now, we will load the page into frame because the page size is equal to the frame size. This division is carried out in such a way. Okay. So, this is the paging, but there suppose we have a this is our logical memory, our program 3 pages, and suppose this is our main memory, and the partition of main memory again 3. This is frame 1, this is frame 2, and this is frame 3. Okay. Now, we will load the page 1, page 2, page 3 into these frame. So, one method is that we will load all the pages initially in the memory. So, this is a normal paging. But what is demand paging? Demand paging means a page must be loaded only in main memory when only it is referred by the CPU. Okay. Until and unless the CPU don't demand any page, it should not be loaded into frame in advance. Okay. So, demand paging means a page should be loaded in frame only when it is referred by the CPU. It means CPU basically generate the logical address, and that logical address will belongs to a particular page. It means CPU want to access that particular page. So, at a particular time, whenever CPU generate a logical address, then page to which that particular logical address belong, that page should be loaded into main memory. So in case of demand paging, the page must be loaded only whenever it is referred or requested by the CPU. Until and unless a page is not referred by the CPU, then there is no need to load that particular page in advance in the main memory. This is our simple concept of the demand paging. Next, here this is main memory and this is secondary memory. Again, there is a process which is known as the swapping. So swapping pages process is also used in case of demand paging. It means, suppose initially there are two process P1 and process P2. We have divided the process P1 into 5 sections, or we can say that there are 5 pages A, B, C, D, E. Again, there are 5 pages in process P2. This is our secondary storage hard disk, or this is hard disk. This is our main memory. This is secondary storage logical memory. Okay, here the page is divided again this. So this page will be loaded into this frame. This is our frame. Sorry, this is the main memory. So this division is frame 1, frame 2, frame 3. This is frame 4. This is frame 5. Now this is logical memory. Here page 1, page 2, page 3, page 4, page 5. Okay, now these pages, page 1 is loaded into frame 1, page 2, frame 2. Okay, so at a particular time when this particular main memory become full, then there is a need to swap out the process from main memory to secondary storage. It means swapping is a process in which the pages move from main memory to secondary memory and from secondary memory to main memory. So when a particular page is loaded from secondary storage to main memory, or when a particular page is bring from main memories from secondary to main memory, then this particular operation is known as swap in. And when a page is removed from main memory and it is sent to the secondary memory, then this particular operation is known as the swap out. And the combination of swap in and swap out is known as the swapping, which is a process of moving the pages from main memory to secondary memory and from secondary memory to main memory. Okay. Now, what is the page replacement algorithm? Page replacement algorithm is an important concept. It means this is the process of swap in and swap out. So when a particular, there are 5 pages. There are 5 pages F, G, H, I, J. Then which process will be moved to the secondary? It means which process will be removed from main memory. Then this decision is carried out by the help of page replacement algorithm. Okay. Suppose in main memory there is a space to load the 5 pages. Now main memory becomes full after loading the 5 pages. Now we have to load the page number 6 into main memory, but there is no space in main memory, and we have to execute the process P6. We have to load the process P6, page P6. Then how we will do that? In that case, any one of the page from main memory will be moved to the secondary storage. Space become free in main memory, and in that free space now we will load the page 6. So all this decision is carried out with the help of page replacement algorithm. It means page replacement algorithm simply decide that which page will be replaced from main memory or which page will be swapped out from main memory in case whenever a new page arrive and there is no memory space available. Okay, so we have to create the memory, we have to become the memory space free to load the new page. In that case, we have to swap out any one page. So for that decision is carried out by the help of page replacement algorithm. And basically there are 3 types of page replacement algorithm. First is the first in first out page replacement. Next is the optimal page replacement, and next is the least recently used page replacement algorithm. So first we will see the concept of the first in first out page replacement algorithm. The concept of first in first out is very simple, that the page which is reside in main memory from the beginning, or which is loaded first in the main memory, that will be selected for the replacement. It means in which order the process are coming or loaded into main memory, in that order process will be removed. So which process will come first, that will be removed first from the main memory in case of FIFO page replacement algorithm, if there is a need to free the memory space to load the new process. So this is the problem based on the FIFO page replacement. We have a page reference string 701203, okay, and we have 3 frames in main memory 1, 2, 3. and these pages are referred by the CPU. Now we have to load these pages in main memory. Then in this problem, we have to find the total number of page fault. Okay, so initially when the first page 7 is referred, then our initially all the 3 frames are available free. Okay, so there are two concepts, page miss and page hit. So if the page referred by the CPU is not present in main memory, then this is count as page miss. And if the page referred by the CPU is available in main memory, then this is known as the page hit. Or okay, so if not available, then page miss or page fault. We can say that page fault occur if the page referred by the CPU is not present. So initially memory is free. There are 3 frames. So first is 7 is referred by the CPU. Since 7 is not available in main memory, so what memory space is available? 3 free frames are available. So here the page fault will be 1 and we will load the 7. Now again next page is 0. 0 is not available, but free frame is available. So we will load here 0. Page fault is 2. Now next page is 1. 1 frame is available. We will load it. 1 is not available. Again page fault is 3. Okay. Now there is a reference of page 2, but memory space is not available. Page 2 is also not available. So page fault occur. So value of page fault will now become 4. But we have to load the page 2. So again CPU, as per the CPU concept, the page which is loaded first into main memory, that will be selected for the replacement. So page number 7 is loaded first into main memory. So page number 7 will be swapped out from main memory, and page number 2, which is currently referred by the CPU, will be loaded in that particular space. So now the memory status will be this. Now again next page is referred as 0. 0 is present in main memory. So value of page fault will not count, will not be increased because 0 is already available. Now 3 is not available. So value of page fault will be 5. Okay. Now to load the page number 3, we don't have enough space in main memory. So which page will be selected for the replacement? So again the page which there are 3 pages, 2, 0, 1. Among these pages which arrived first in main memory, that will be selected for the replacement. So page number 0 arrived first. So it will be swapped out and page number 3 will loaded into main memory. Again next is referred by the referred page number is 0 and page 0 is not available. So page fault occur, and when page fault occur, then value of page fault will be increased by 1. So now the page fault is 6. Okay. And among these, which place will be selected page for the replacement? Page number 1 is selected for the replacement. So page 0 will be loaded here. Okay. Again 4. Page 4 is also not present in main memory. So value of page fault will increase by 1. Page fault will become 7. Now among these 3 pages, which arrived first? Page number 2 arrived first. So 2 will be selected for the page replacement. So 4 will be loaded at this place. Okay. Now page 2 is not available in main memory. So value of page fault will increase 8. Now among these 3, page number 3 will be selected for the replacement because 3 loaded first in main memory. So this will be the status after loading 2. Next page 3 is referred by the CPU and page 3 is not available in main memory. So among these 3 page fault will occur. Value of page fault increase by 1. It will become 9. Okay. And page number 0 is selected for the replacement. So this will be status. After this, the page number 0 is referred. Again 0 is not available here main memory. So among these 3 processes, which is loaded first? 4. So 4 will be selected for replacement, and since value of page fault increased by 1. Next page is referred by 3. Since 3 is available in main memory, so there will be no page fault, and no page fault is so value of page fault will not be increased by 1. Again next page referred by the CPU is page number 2. And page number 2 is available. So value of page fault will not be increased by 1. Next, page referred by the CPU is 1. Now the page number 1 is not available in main memory. So when a page referred by the CPU is not available in main memory, in that case value of page fault will increase by 1. So now the page fault becomes 11. Okay, and again among these 3 pages which arrived first, that will be selected for replacement. So page number 2 will be swapped out from main memory and page number 1 will be loaded at that place. Okay, so this will be the status. Now page 2 is referred by the CPU and page 2 is not present in main memory. So page fault will increase by 1. Value of page fault become 12. And among these 3 pages which arrived first, that will be selected for the replacement. So page number 3 will select for replacement. So this will be the status. Next, page referred by the CPU is 0. And since 0 is present in main memory, so there is no page fault. So value of page fault will not increase. Again, next page referred by the CPU is 1. And since page number 1 is present in main memory, so value of page fault will not increase because this is the page hit. Okay. Next, 7. Page number 7 is referred by the CPU. And since page number 7 is not available in main memory, so this is page miss. And now the value of page fault will increase by 1 and this will become 13. Among these 3 pages which arrived first, page number 0 arrived first in main memory. So page number 0 will be selected for the replacement. It means page number 0 will be swapped out from memory and page number 7 will be swapped in. Okay. Next one is the 0. 0 is not available in main memory at this time. So page fault, this is the condition of page miss and the value of page fault increase by 1. So page fault become 14. Now among these process which arrive first in main memory, 1. So page 1 will be swapped out and page 0 will be swapped in at that place. Okay. Now page 1 is referred by the CPU. Page 1 is not present in main memory. So this is the condition of page miss and value of page fault will increase by 115. And among these 3 processes which arrived first in main memory, page number 2. So page number 2 will be selected for the replacement. So it will be swapped out from main memory and page number 1 will be swapped in. So after complete, now the complete string is referred. Okay. So after complete string reference, there will be total number of page fault. Page fault will be 15. Okay. And this will be the final status. So in the page replacement algorithm based problem, a particular page reference string will be given and some number of frames will be given in main memory. Now we have to find the page replacement, total number of page fault in that particular policy. So if we apply the FIFO page replacement algorithm for this particular problem, then total number of page fault become the 15 and this will be the final memory status. Next one is the optimal page replacement algorithm. So in case of optimal page replacement algorithm, the page which will be referred after a long time, that will be selected for the replacement. Okay, we will understand it with the help of a problem. Suppose this is again a problem and now we have to apply the optimal page replacement algorithm on it. So first initially there are 3 frames in main memory and all the frames are available free. So first page referred by the CPU is 7. 7 is not present. So free frame are available. So page fault is 1 and we will load the 7. Next 0 is not available in main memory. Page fault increase 2 and frame available. So 0 is loaded. Next 1 frame available. Page fault will be 3 and loaded. Now next page is 2. So when CPU is referring page number 2 and since page number 2 is not present in main memory, so we have to use the optimal page replacement algorithm now. It means which page among 7, 0 and 1, which page will be selected for the replacement using the concept of optimal page replacement algorithm. Then we will move in forward direction and we will see that among these 3 pages 7, 0 and 1, which pages is referred late in future. Okay, so that page will be selected for the replacement. So 0 is referred just after the 2, so 0 will not be selected. 1 again we will move in forward direction, 1 is referred here and 7 is referred in the last. So page number 7 will be selected for the replacement, because 7 is going to use after a long time in future. So say page number 7 will be swap out and page number 2 will be swap in, and page fault becomes 4. Now next page referred by the CPU is 0. 0 is available in main memory, so there is no page fault. This is the page hit condition. Next page 3 is referred by the CPU. 3 is not available in main memory. Again page fault will increase, value of page fault become 1. Now which page will be selected? So from 3 we will move in forward direction, and we will see 0 to 1 is going to use in the last. So 3 will 1 page 1 will be swap out and 3 will be swap in. Again next page is referred 0. 0 is available in main memory, so no page fault. Next 4. 4 is referred. 4 is not available in main memory, page fault occur, value of page fault becomes 6. Then which page will be selected for replacement? So 2, 3, 0, 2, or so 2, 3 and 0. 0 is 2, 3 and 0. 0 is going to use in last. So 0 will be swap out. This will be the memory status. Next 2 is referred. 2 is available, no page fault. 3 is referred. 3 is available, no page fault. Next 0 is referred. 0 is not available. So we will so page fault will occur and page fault becomes 7. We will move here in forward direction. So page number 4 is not going to use in future. So 4 will be swap out and 0 will be swap in. Next 3 is available, no page fault. 2 is available, no page fault. Now 1 is not available, page fault occurs. So value of page fault become here 8. Now in this situation, from 1, 2 is referred just after the 1, 0 is referred, 3 is not going to refer. So page number 3 will be selected for the replacement. Again 2 is referred, available in main memory, no page fault. 0 is referred, available in main memory, no page fault. 1 is referred, 1 is available in main memory, no page fault. Now 7 is referred, 7 is not in main memory. So value of page fault become now 9. It will increase by 1. Okay. Now in this case, which page will be selected for the replacement? So 0 and 1 is going to use, but 2 is not going to use. So 2 will be swap out and 7 will be swap in. 0 is available, 1 is available. So total number of page fault becomes now, if we apply the optimal page replacement algorithm in this problem. So generally the performance of optimal page replacement algorithm is better as compared to the FIFO and recently used LRU page optimal replace. Okay, a particular page replacement algorithm is better, in which the number of page fault are less. So in case of FIFO, page fault will be 15, but when we applied the optimal page replacement algorithm on the same problem, then the value of total page fault is 9. So it is better as compared to the FIFO policy. Third one is the LRU, least recently used. In case of least recently used algorithm, the page which is recently used, latest, which has not been used from the longest period of time, we will move in backbar direction and we will see that which page is not used from the larger period of time, that will be selected for the replacement. For example, suppose this is a string and there are 4 frames in main memory. Now we have to apply the least recently used LRU algorithm for the replacement and we have to solve it. Okay, so initially 4 frames are available in main memory here. So 1 is referred, frame are available, page fault, 1 is not present in main memory, the value of page fault become 1. Now 1 is loaded. Next 2 is not available in main memory, but frame available 2. So page fault become now 2. Okay. Next 3 is not available, page fault become 3 and frame is available. So we will load 3. Next 4, frame is available but page is not available. So page fault become 4. So here this is the status and page fault become 4. Now after 4, when the page number 1 is referred, so 1 is already present in main memory, so value of page fault will not increase because this is a page hit condition. Now 2 is referred, 2 is available, so no page fault. 5 is referred, 5 is not available in main memory, so page fault occur, so value of page fault will become 5. Then which page will be selected for the replacement? So we will move in the backbar direction and among 1, 2, 3, 4, which page has been not used from the not referred from the longest period of time. So 2, 1, 4 referred just before the 5. So 3 is referred from the longest, not referred from the longest period of time. So 3 will be selected for the replacement. It means 3 will be swap out and 5 will be swap in. Now again 1 present in main memory, no page fault. 2 present in main memory, no page fault. 3 is not present in main memory. So this is page fault. Again value of page fault will increase by 1 and it becomes now 6. So we will move in backward direction and see that which is going not referred from the longest period of time. So 2, 1, 5, this is just referred before the 3, but page number 4 is not referred from the longest period of time. So page 4 will be swap out and 3 will be swap in. 4. Now here 4 is not present in main memory, so value of page fault will increase by 1. It will become now 7. So which page will be selected for replacement? 3, 2, 1, 5. 5 is not used or not referred by the CPU from the longest period of time. So page 5 will be swap out and page 4 will be swap in. Again 5 is not present in main memory here. So page fault will occur and value of page fault increase by 1. Now among 1, 2, 4 and 3, which page will be selected for the replacement? We will move in backward direction and see that which page is not referred from the longest period of time. So page number 1 is not referred. 2, 4, 3, 2 is just before the 1. Page number 1 is not referred from the longest period of time. So page number 1 will be selected for the replacement. It means page number 1 will be swap out and page number 5 will be swap in. So if we apply the LRU policy on this problem, then total number of page fault become 8. Okay. So these were the concept of the different page replacement algorithm, FIFO page replacement, optimal page replacement, and the least recently used page replacement algorithm, which are basically used to replace the page when there is not enough space available in main memory. Okay, thank you.